We continue in our discussion of the production process and the production questions by considering what's called the production possibilities curve. The PPC, or production possibilities curve, illustrates the principle of constrained choice and scarcity to address the question, what should we produce? Let's take a simple example here. An economy, let's imagine, where we are able to produce only two goods, corn and wheat. And you can see this leftmost column here gives A, B, C, D, represents the combinations of corn and wheat production that you see provided there for you. In other words, if we produce at point A, where we're producing the maximum amount of corn, 720 bushels, that means we're producing 0 wheat. In other words, we're devoting every resource we have to produce corn, and therefore have nothing to devote to producing wheat. As we go to point B, you see that we gain wheat production, but it's only at the sacrifice of corn production. In other words, if we take resources away from corn to produce wheat, we're going to get lower corn production. As we proceed to C, D, and so on, we eventually reach a point where we're producing all wheat, or at least we should say the maximum wheat we can produce, given those resources, 635 bushels, and we're producing 0 corn as a result. Well, let's go to the next table here and see this. See what the implications for this decision are. Notice again in the 3 leftmost columns, that's really the table that we had on the preceding slide. And then I'm describing here a move, for instance, going from A to B. We notice that we gain wheat production, but we give up corn production. And so there are 2 columns there. Notice the one is labeled gain in wheat, and that's where we write the number of bushels of wheat, additional or marginal increased production in wheat that was made possible in moving from A to B. But also notice in that next column, sacrifice in corn, where we might say that's a cost in one sense. The cost in corn of that additional wheat production. Well, notice as we go from point B to point C, then once again we are giving up corn production in order to produce more wheat. But we'll also notice here that in fact that cost is a bit higher. Well, let's see how we determine that. First of all, go back to point B, or to that combination at point B. We notice in going from A to B, we gained 100 bushels of wheat, but we lost or sacrificed 20 bushels of corn. And so notice that next column. We say that's the cost of wheat in terms of corn. In other words, that's the number of bushels of corn production we gave up in order to gain the wheat production that we obtained in that period. And so notice if we gave up 20 bushels of corn to get 100 bushels of wheat, then we would say the cost is 0.2, that is 0.2 bushels of corn for every bushel of wheat that we gained. Well, let's go to point C. Notice there, in going from B to C, again we gained 100 bushels of wheat, but we gave up 50 bushels of corn this time, a bit more than than going from A to B. And so the ratio, that is, the cost of the corn that we gave up relative to the wheat that we gained, is now 0.5. We gave up 0.5 bushels of corn production for every bushel of wheat, of additional wheat production. As we keep going, one thing you see is that cost goes up. As a matter of fact, it never goes down. It just gets higher and higher. Imagine that what's happening here is, let's say that at some point in there, we are using the ground, the resources that are best suited for corn production, for corn, and those resources best suited for wheat production, we're gaining wheat. But let's say if we decide to go in either direction, we want to produce more wheat, and so we actually then start devoting resources that would be better for corn. If we start devoting those to producing wheat, we can imagine that we're going to lose more corn and not gain quite as much wheat in return. And so as you go down and follow from C to D to E, I encourage you to prove those calculations yourself to make sure you see that as we go further along this curve, we are giving up more and more and more corn for the increments of wheat that we are getting. So notice by the time you get to point I, where you're producing the maximum amount of wheat, your wheat is going to cost you 6.67 bushels of corn. Now this is still not going to tell us anything about how many units we should be producing, because in fact we don't know what the actual value of a bushel of wheat or a bushel of corn is. And so we can't make that decision. We're just now facing up to the realities of production, and again this notion of production and constrained cost in the face of scarcity. Now you can go ahead and calculate those costs of corn in terms of wheat by, for the most part, just reversing the order. Start down at I, point I, and that's when you're producing all wheat and no corn, and just say, hey, what happens if I give up wheat production and to move from point and gain corn production, move from point I to point H? And what you would see there, of course, is you gain 100 bushels of corn, but you give up, what's that, 15 bushels of wheat. And so the cost of corn in terms of wheat would be 15 divided by 100. It would be a pretty low amount. But as you move back up the chart, what you would find is that as you produce more and more and more corn, you're going to give up successively greater and greater and greater amounts of wheat, so that in fact it's the sort of the reverse order that we see in that column where we're calculating the cost of wheat in terms of corn. Now that's a table. This is how to address that. This curve is how you demonstrate it, or how it's demonstrated graphically. Now what I encourage you to do is make sure to draw this graph and to label those points so that you can see that this curve demonstrates the actual data sets that you're dealing with there. What you notice, by the way, is this graph, the graphing of this set of relationships here is a convex curve. That it's outward bowed curve, and what that means is that as you move along the curve, that it is whichever way you're going, the function's value or result is increasing at an increasing rate. In other words, as you decide you want to produce more wheat and move along that curve, you are giving up successively more and more, I should say proportionally more and more corn in order to do so. And so you would see that that slope, for instance, of this curve here is not only negative, but it's increasingly negative as you move from left to right. Now, this production possibilities curve demonstrates, or can be used to demonstrate, a number of concepts. First of all, the notion of scarcity. Scarcity here simply says, essentially, in order to get more corn production, you've got to give up wheat production, and vice versa. You can't have it all. Every increment, every movement along that curve demonstrates a production level that increases the production of one commodity and decreases production of another. There's no way to avoid that. Unemployment is demonstrated here. If you've got, for instance, land or other resources that are underutilized, then the production that's possible would not fall along this curve. This curve doesn't tell us what the optimal level of production is, but it does demonstrate for us a possibilities frontier. It's sometimes called production possibilities frontier, and that means that it represents the very best possible output for a given level of input. So every point along that curve represents, let's say, the maximum output of the two commodities that are possible. Anything inside, if you were to draw a point inside the curve or just mark a point, that would represent a point of production that represented unemployment of resources, or also inefficiencies. That is, if you're not properly utilizing the resources that you've got. Opportunity cost, again, this is the notion that if you want to produce more of one item, you give up something else. And again, we don't know the actual values, the dollar values, for instance, of these commodities. So we can't really determine what is the very best combination of corn and wheat to grow. But we do, again, notice that, realize that in order to produce more of one item, you give up production of something else. It's the value of that foregone benefit that represents the opportunity cost. The law of increasing opportunity cost, or the law of diminishing returns, is demonstrated by the convex shape of this curve. That is, the more you want to produce another 100, from any given point, another 100 bushels of wheat, you're going to have to give up more corn than you did to produce that last 100 bushels of wheat. And the further to the right, for instance, you move, the more wheat you have to, the more of one commodity you have to give up for the other to get the other. Economic growth is demonstrated not so much on this curve, but if we were able to say, for instance, that the new technology has enabled us to produce more corn without, given the current resources that we have, then actually would find that the curve moves outward and allows a whole new set, really, a whole new production possibilities frontier. Well, let's talk about trade in terms of trade. 3 relevant periods for discussing trades: ex ante, that is before the trade, the point of trade, and ex post, after the trade. The ex ante is before, and in free markets, we assume that people are trading for their own benefit, and they will not engage in a trade unless they believe it's going to be to their benefit. That's why we say that trades in free markets are win-win. Both parties believe they're better off with the trade than without. Otherwise, they wouldn't be trading. We also know that after the trade, all of us have bought something that we wish we hadn't, or found out it wasn't what was advertised. But anyway, those 3 points are really important in understanding trade. How much of an item is given up for how much of something else represents, of course, the price at which something is traded. Costs of trades include transactions costs, costs of time and effort to bring about a trade, including commissions, shipping, transportation, and even uncertainty represents a cost of trade, not knowing whether you will get what was advertised. Transaction costs can prevent a potential trade from becoming an actual trade. I've eBayed for a long period of time, and if you have, then you look at the number of positive comments, for the reviews of a particular seller, especially if you're talking about a big dollar item. You're not going to send $2,000 to somebody that hasn't got a really good record as a seller. Voluntary exchanges are assumed to benefit both parties. Otherwise, why would they trade? That's why we talk about, again, the win-win notion for free market transactions, voluntary transactions. There are, though, what are called third-party effects that are sometimes, when they're adverse, called negative externalities. For instance, one person sells a gun to someone else. They're both better off, or believe they are, than that person who buys the gun does harm to someone with it. Or two people, one buys drugs from someone else, and then uses those and, let's say, loses control of a vehicle and hurts someone else. Those are negative externalities. The two parties to the trade may believe that they were both better off, but in fact somebody else, not a party to the trade, was affected adversely by it. We'll continue later.